Fantastic. Okay, so the first thing we are going to do is go over the course outline. So if you go to your classroom, which you've all joined, in the About section, just click on About, and then there's the Google Drive folder. So that's the folder where you'll have all of your information. So if you click on that, go under Course Notes, and Summer School. Over a couple of things before we get started about the class itself. So you are registered in the Bridge course, Secondary 4TS. So the expectation is that you did, just before I get started, everyone can hear me? Everyone wave, make sure we're good to go.
Yeah.
Yes, fantastic. Okay. So basically, you're in the Bridge TS, Secondary 4TS. So this is the course to bridge you to this class. So the expectation is that you have passed a Secondary 4 CST, or you've taken a Secondary 4 CST this year and were recommended by your teacher and your school. So we'll just take a look at this class and what it entails. So basically, my expectations from you to be on time to the Hangout. I'll be starting at 8:30 every day. Be prepared. So I will be giving you work to do, quizzes, assignments, just to make sure that you'll be ready for the final in 3 weeks. So just make sure that you're keeping up with that as much as possible. We're trying out this new Hangout thing. So there could be some technical difficulties in the way people talk and pop up all the time. Could be a little bit different, so make sure you're muted. So make sure you are respectful if someone else is talking. Just wait your turn or flag me down. I can see all of your videos if you keep them up, or the chat. So if you have any questions, do not hesitate, but try to be respectful. We're trying this in a new forum, so it could be a little different for all of us. Just like in the class, you're going to have a situational problem in the 3rd week. So not this week, not next week, the week after, on the Wednesday that you come in. So that'll be your sit prob mark. And then you'll have the final the following Tuesday. Okay? In terms of work, you will get homework every class. So there are 3 different ways you're going to get work. I'll go over that after we look at the course outline together. And if you have any questions, like I said, feel free to stop me. Wednesday. So Wednesday's class are the tutorial classes, which means that you're supposed to be in the building with me on that day. So we're going to use approximately the first half of class to go over the material that we did. So in this case, it'll just be Monday, Tuesday. So about the first half going over questions and problems, and maybe troubleshooting any internet issues or computer issues that you're having. Oh, sorry. Okay, so on Wednesdays, like I said, on Wednesdays, the first half of the class, we're going to cover the material that we did before, going over examples, troubleshooting, problems, everything that you guys need. After that, we will be covering some new material. Unfortunately, that will not be videoed, so the expectation is that you are going to be in the classroom. If you're not, for whatever reason, send me an email as soon as possible so we can work some stuff out. I'm always available for extra help, so you can just contact me through Google Classroom. Google Classroom is going to be our main connection for all of the materials, questions, quizzes, assignments, all that kind of stuff. So feel free to email me through there, or my email is directly on this document, up to you. So the big thing to remember here, or to understand, is that we're talking about 2 grade 10 classes. So the first class that you did was in class with your teacher, so the grade 10 CST, and now we have the grade 10 TS. And there is some overlap in terms of the topics between these 2 classes. So if you scroll down here, under topics from CST, the goal of this is to go over as many, we're going to go over all the topics that are new to you. So things that are offered just in the TS and not the CST. But like I said, there is some stuff that comes forward from the CST that you are expected to know. And because we only have 3 weeks together, it's not a lot of time to review all this material. So make sure that you're going over this. And if you have any questions or you want me to go over anything like that, just let me know. Here we've got, so you're expected to know lines, slope, functional form, general form. We will go over this a little bit. Quadratic functions, so for the functions, quadratic, we're going to take a quick look at that together, but not a lot. Piecewise functions, periodic functions, step functions, we'll look a little bit together, and then we're going to do something different with it. In terms of analytic geometry, you have the distance formula, midpoint, division point, parallel lines, perpendicular lines. So these are all things that you should have seen throughout the year. System of equations, the different methods, comparison, elimination, substitution, how to determine number of solutions and different word problems for that. Another thing is triangles, so the theorems for congruence, similarity, similar figures, and metric relations. Trigonometry, SOHCAHTOA, and area. So for this course, for whatever reason, they decided that you don't need sine law. So you still have that as a tool in your toolbox if you want to use it, but it's not expected of this class, so you won't get a question on that per se. And then statistics would be the final topic that you've seen already, mean deviation and the correlation. So the scatter plots, estimating the correlation coefficient, the Mayer method, contingency tables. So all of that stuff you should have covered throughout the year. So if at any point you see something on this list and you say, oh my goodness, I didn't cover this throughout the year, I really, really don't remember it, just send me an email and we can chat about it, or I'll go over it in class, something like that. Okay? So far, so good? Feel free to answer through the chat or anything else. Okay.
Yeah.
Fantastic. Here we go. New topics to be covered. So we have a whole bunch of stuff that we're going to cover together, starting today, obviously, and not too long. Roots and radicals, different operations with that, polynomials, factoring. There's a whole bunch of different stuff that we're going to be looking at together. I don't want you to be too nervous. This week is going to be a little bit algebra heavy, but after that it's a little bit more straightforward, a little less algebra. So don't get too intimidated if today's class is a little bit heavy. They're not all going to be like that. And just as an overview, these are all the different topics we will be looking at together throughout the next 3 weeks. So far, so good. Oh, the schedule says missing topics, new topics, practice. So there are different ways that I'm going to be assigning work to you. Every day you're going to be getting, so if you go back to your About folder here, be your main source of information for everything. So you have access to this just like I do. There are different places that we're going to be working with. So if you go into course notes, these are the course notes that I am going to be going over. So you have a PDF document of all the different notes that I'm going to cover and the different examples that we're going to do together. So you're expected, I'd like you to download it. If you have time to print it before class, it's fantastic. It would probably be very helpful for you to do this because like you see here are some blank spaces where you think you would have something there and you don't. And that's not a mistake. Basically, you are going to fill in missing information. So it'd be really helpful if you could have these printed out. If you don't have a printer or have some issue with that, let me know as soon as possible and we'll try to work something out. But that's where you'll find your course notes. Every day, the night before, at least, if not earlier than that, you'll have the course notes for the next day. So you can download that, print it, take a look at it if you want. What else we got here? So these are the questions for practice we'll have to work on each different day. So this one's called class 1. You'll have class 1, 2, 3, 4, 5, etc., etc., and you'll be able to go over all of this as practice for you. The answer keys to this will be obviously found in answer keys, pretty self-explanatory on that one. Links for the Hangouts should be in here, still working on getting this as soon as possible. Otherwise, they'll be posted directly in the feed for the summer school. Other than that, we're good to go. So far so good?
Yeah.
Okay.
Yeah.
So in your feed, I'm assuming or hoping that you're all familiar with Google Classroom, and if you're not, that you've looked over the tutorial that was provided to you when you registered. If not, take the time to really just take a look at it. It's quite simple to look. They made it look like Facebook kind of thing, so you'd be a little bit familiar with how it works. It is what it is. So I'm just going to be posting everything here, your assignments and any notes and the Hangout links and the solutions to your assignments as well. So the thing that we're going to be doing together is going to go through. So it's super important that you familiarize yourself with everything that you've got here. So the first thing that I want to do is go over the practice assignment, because for assignments, we're going to be doing a couple of different things. I'm going to edit this because for some reason it doesn't seem to be working. So there are 3 different things that we're going to be using as ways to get feedback from me. Okay, so on the handout itself, that's for you to practice and you'll have the answers, and if you have questions about it, we'll go over it together. But there are certain ways that I would like to get feedback from you. Okay, so we'll probably be using Google Slides, Google Docs, and Google Forms. So 3 different things here. So what I'd like from you is we'll take a look at each of them together. This is just a test quiz. It's Google Forms. Basically, you click on it, you fill out the questions, multiple choice, short answer, and submit the quiz, and then I get feedback. You get the answer key, so you'll know if you're right, wrong, whatever, and then I'll get feedback as to how you guys are doing. You want to take 2 minutes now. I see there are quite a few of us logged in, so if you want to just take a quick second, we'll take a look at this. So just take a minute, click on it, fill it out, so we can make sure everyone's familiar with how to use it. Still waiting on a few people. All right. Okay, so we've got about 12 responses here. So everyone's good with the Google form? Good to go? Okay. So like I said, the other two ways that we're going to be, the other two things that we'll be doing here are Google Slides and Google Docs. So basically, what I'm going to do is I'm going to have a problem uploaded. So here you see practice assignment in the Google Slides, calculate the distance between 4-7 and 12-18. So you have 12-18. So you have two choices. You can either actually do the calculations there because they have an equation tool if you want. Otherwise, you can do it on paper, take a quick picture of it, and just upload the picture onto the assignment. So I would recommend that way. It seems more straightforward, less likely to make mistakes, and way easier, in my opinion, than trying to use a formula thing if you want to do a problem in more quickly. Otherwise, feel free to use whichever way you're comfortable with. It will be the same with Docs. You'll be doing a problem and then uploading it into a text box that I've provided. So the reason I have a text box very specific is because if you just upload a random picture, we've all used Google Docs, all of a sudden the picture goes in the middle and everything messes up. Things shift, they go everywhere. So it's just easier if you put it into the text box. That way everything stays where it's supposed to be. So here, if you're calculating the area, you can do it on a piece of paper, you write it out, take a picture, upload it into the text box. Once that happens, you have a due date. I'll take a look at when it's due. And I can go in and I will be providing you feedback. Okay, so I will take a look at each of your assignments. So I see a lot of people haven't tried the Google Doc yet. So hopefully we'll be testing that out as soon as possible. But basically, I will go in and I will provide you with feedback for each of those questions within a day or two. So that way you know what you're getting right, what you're getting wrong, and what your mistakes are. So this will be more for the Google Doc, and the Google Slides will be more for long questions, the process kind of questions, which are harder to get feedback on through a Google form. And the short answer questions and the multiple choice questions will go through the Google Forms. So the final is laid out exactly the same as you had for the CST. So one section for multiple choice, one section for short answer, one section for long answer. So we're trying to hit on all those three types through these three things together to give you as much feedback as possible on the new material. Okay? So far, so good. I just threw a lot of information at you. Hopefully, we're all feeling good about it. Okay, so take the time at some point today to do this just to make sure that you don't have any issues with it. We'll be giving you an assignment today on the material that we covered today. So this would be a good time to practice to see if you know how to do it before you have the assignment that you're actually expected to be completing. Okay, so like I said, if you have any questions, flag me down, feel free to ask. I'll go well. Okay, so this brings us to new material, okay? So like I said, this class specifically and next class probably, this week overall will be algebra heavy, so don't get discouraged, don't get intimidated. It's not too bad. Like I said, you saw the list of topics that come back from CST. So you already have a very, very solid foundation for this course. We're just covering the stuff that you haven't seen before. So do not forget that even if you have a little bit of difficulty with one or two of the topics that we covered together, that you still have a really, really solid foundation in the other topics. And it's an exam on the whole thing as all the topics together as a whole. Okay, everyone good? All right, so like I said, here you have these notes in the folder on Google Classroom. Anything that is blue on these notes is not on your copy, which means that you need to write this down. I do this so that you'll actually join the Hangout and listen to the lectures, because without that, you will not get these pieces of information. So anything in blue you do not have, and you need to copy down. All right. So the first thing we are going to be doing is a little bit of review, and then we'll jump into the new material. So exponents. So remember, for exponents, we have several different rules. So we're going to go over all of these rules together. So just in terms of identities, we have that anything, a to the power of 0, a being any number that you want, here, no matter what, is equal to 1. So anything to the power of 0 is equal to 1. I just want to change my pen color here, don't mind me. Beautiful screen. Okay, we also have that anything to the power of 1 is just that number. So 2 to the power of 1 is 1, 10 to the power of 1 is 1, yada, yada. Finally, we have that anything to the power when you have a negative exponent. Basically, a negative exponent is an exponent that is not happy where it is positioned. Okay, so all you have to do to take care of a negative exponent is put it on the bottom half of the fraction. So if it's on the top, it goes to the bottom. If it's on the bottom, it goes to the top. Negative exponents not happy, they get repositioned. Okay. We have several rules for exponents. So when we have, so very, very specific, we have to have our bases here. This is for the same base. We notice we have A every single time. That's our base, which means that these work for things that have the same base only. Otherwise, we can't combine something that doesn't have the same base. So I have a to the m, and I have a to the n. If I'm multiplying those two terms, how do I put them together? I have a to the power of m plus n. So when I'm multiplying terms, I add the exponents. Okay? It's similar for quotients. So if I have a to the m divided by a to the n, we have the same base. We have our exponents. And when we're wanting to put it to one term together, we subtract the exponents. So that gives us a to the power of m minus n. Power of a product. So if I have two things here, they're multiplying, and they have the exponent on the outside. What happens to this exponent is it gets distributed to every term within the bracket. So what this gives me here is a to the n and b to the n. Same thing, power of a quotient. Obviously, it works the same way. We have two terms that are being divided within a bracket. We have this exponent here on the outside that we are working with. So that exponent gets distributed to both terms within the bracket at the top and at the bottom. Finally, power of a power. If you have a term, exponent, already present, and you are taking that to some sort of power, in order to find the exponent, you just multiply them here. So I have the power of m to the power of n, I multiply the exponents to get me my result. Okay. Questions so far? Fantastic. So we'll do some refresher examples here. So like I said before, you have all these examples in the handout that I gave you. If I go at any point, go too fast down the notes, you miss something, you want me to go back and explain it, please, please, please flag me down. This class is for you, and I want to make sure that even though I can't see you, you're not sitting right in front of me, that all your questions get answered regardless. Okay. So here we go. You'll also have to bear with me. I got this new little technological tool to help me write on the smartboard on my laptop, but I'm still working out the details, and it's a little bit funky in terms of where things go. So my writing might be a little messy for the first day or so while I get used to this. All right. So here we have -5 to the power of -2. So how do we deal with this? Well, let's first of all deal with just this. So negative 5 to the power of 2 gives me positive 25. And I still have the power of negative 1. Anything to the power of negative 1, we just saw before, gets put to the bottom. So I have 1 over 25. All right. So each time we're just applying a different rule. So here we have, for the second one, 2 to the 3 divided by 2 to the 5. What we do in this case is we're going to subtract because we have a division. But to make our lives easier and to do this in one step, what we are going to do is we are just going to subtract the bigger exponent minus the smaller exponent. Okay? So I put this line here, and I say 5 is bigger, so I go 5 minus 3. That gives me 2. I position it where the 5 was, so the 2 to the 2 goes to the bottom, and I have the 1 on the top. The other way you could have done this would have been to say, okay, I'm just going to subtract 3 minus 5. That gives me 2 to the negative 2. But I know I can't have answers that have negative exponents, so this needs to go to the bottom anyway, and it needs to be 2 to the 2 on the bottom. So doing it this way just skips the middleman. You don't end up having this step to deal with, but whichever one you're more comfortable with. All right. This one's a little bit trickier. So here we've got negative 2 to the 3 to the power of 2. So what I'm going to do just to make this a little bit more clear, I'm going to write it out like this. Because whenever we have a squared, that means I have this term multiplied by this term. Okay? So we see here that this negative and this negative are actually going to cancel out. And I'm left with 2 to the 3 plus 2 to the 3. We now know that we have, when we have multiplication of exponents like that, we add them up. So I get 2 to the 6. All right. We're going to go to number 5. Skip number 4, it's very similar to number 2. Number 5. Here we've got the power of a power. So the first thing we're going to do before we start putting things together is we're going to distribute that power here. Okay, so each of these, this power gets distributed to each term within the bracket. So 2 to the 3, a to the 3, and the same thing happens here. 3 to the 2, a to the 2. If you want to turn these into numbers, you can. So 2 to the 3 would give me 8. A to the 3, 3 to the 2 would give me 9. Numbers go together, so the 8 and the 9 give me 72. A to the 3 and a to the 2 gives me a to the 5. That is it. Alternately, you could have just gone from here to here, and most of the time the answer will be acceptable, just like this. But you need to be familiar with both ways, because in a multiple choice question you wouldn't have the luxury of presenting your answer however you want to. You'd have to find the solution that they're giving you and match it to what you're doing. But in a short answer or a part C question, perfectly acceptable to do either one of these things. All right, let's take a look at number 6. So number 6, we've got the power of a power, we've got a division, we've got a whole lot going on here. So let's take care of one thing at a time. So the first thing I'm going to take care of is, bear with me as my thing goes a little crazy, this power here. So it's going to get distributed to every term within the bracket. Okay, so 2 becomes 2 to the 3. a squared becomes a to the, we have power of a power, so we have a to the 6. 3 also gets taken to the power of 3, and b gets taken to the power of 3. We have our division. Same thing here. We get a to the 2 times 3 gives me 6, and b to the 3. We are dividing fractions. And when I divide fractions, I flip the second one and turn it into a multiplication. So 2 to the 3, a to the 6 over 3 to the 3, b to the 3 times these flip. B to the 3 over a to the 6. We now have a to the 6 and a to the 6. Well, those are going to go away. I have b to the 3 and b to the 3. Those cancel right out. And I'm left with 2 to the 3 over 3 to the 3. You can make those numbers. You don't have to if you don't want to. That is fine. How are we feeling so far? Not too bad, I hope. This is hopefully a review from secondary 3, but it will help us a lot in the topic that we're going to be doing in not too long. All right, we'll take a look at number 7 just to finish off here. Okay. We're going to distribute this -3 to every term within this bracket. So we get 2 to the -3. A to the 3 over 3 to the -3, a to the -6. What we have here is a whole bunch of exponents that are not very happy because they're all negative. So we're going to flip some stuff around. So anything that's negative needs to shift. So this is negative, it's on the top, it needs to go to the bottom, and it becomes positive. This a to the 3 is quite content at the top. This 3 to the -3, not so happy. This a to the -6, not so happy either. What does this give me? Well, these can be combined. 3 to the 3, a to the, we have a to the 3 times a to the 6, therefore we add the exponents, and we have 2 to the 3 to finish off. So far, so good.
Sorry, could you just scroll down just a bit?
Scroll down? Sure.
Yeah, just a little bit.
Absolutely. Yeah, it gets cut off.
Awesome. Thank you.
All right, we good to go? Okay, so now we're starting a bit with the new material, a bit with something you've probably seen some of before, which will lead us into the real new material here. So roots. So you hear the term square root all the time. So a root is actually an exponent, okay? So what you have is we are taking an exponent, but it's actually a fraction. So here we have a to the power of numerator over denominator. So we have a to the power of 1/6, for example. We can also write this as, actually we're going to write this as 5/6, just so I can illustrate my point a little bit more clear. What this actually means is, what I am doing is I'm taking the 6th root of a to the 5. So you have that little button on your calculator that allows you to take the roots of something. 6th root, 5th root, 3rd root, whatever. If you don't see anything, if you just have the root of 5, that actually means we're taking the 2nd root of 5. So if you don't see anything, that's magical number 2. And we're going to be working with this a lot. A lot today. So same thing here. So actually, if I wanted to write this as a fraction, I would write it as 1/2. So this being your exponent. exp. So as they are an exponent, the laws of exponents still apply. So all the laws that we just saw before, those all still work. It just becomes a little bit more complicated because now we're adding, subtracting, multiplying, dividing fractions, and no one likes doing that. Lucky for you, for the most part, any scientific calculator has a fraction button. I don't know if a lot of you have used that. You should try to find it if it has it. It is your best friend when it comes to stuff like this, anything fraction related. If you're not sure if your calculator has a fraction button, take a picture of it and send it to me. Email, Google Classroom, post it, whatever. I'll show you how to use it. It really saves your life for a lot of different things to do with fractions. All right, so same rules apply. I have a division. A division means I subtract the exponents. So here I have 3 over 2, and I'm actually going to subtract 2 over 3. And a trusty little fraction button on my calculator that'll do this calculation for me. If I do, I get 8 to the 5 over 6. So I don't have to add, subtract, common denominator, do all that nonsense here on the side. We do not want a decimal exponent ever, okay? Just nasty, nasty. So you want to, as much as possible with that fraction button. All right, here we have a power of a power. So same rules apply. We're going to have 2 over 3 times 9 over 8. And of course, that wasn't supposed to happen, but I'll just rewrite it.
Miss, for the question 1, how did you get rid of that second A?
When you're dividing, go back here. It's a good question. Here in our rules, when we divided something, here, this one here. When you divide something, you just put the bases together, it becomes one base, subtract the exponents. So this symbol means divide. So it doesn't matter here that it's displayed as one of the division symbols, it's still a divide. So what happens, at one base, I just take the exponents and I subtract them.
Thank you.
And then I can put them together. Pardon?
Thank you.
Perfect. Okay, so here, in this case, we have the power of a power. We multiply. We use our handy little fraction button on our calculator to do our calculation. And we get, this is to the power of 3 over 4. This works the same with numbers, so we're going to jump to number 4, actually. We'll take number 3, we'll do that after. We're going to jump to number 4. So we have a power of a power here. What this means is every single term within my bracket gets one of those exponents. It gets the 2 over 3. So we're going to write that down here. So 8 gets the 2 over 3. Gets the 2 over 3, and because I'm power of a powering it, they multiply. Y to the 6 gets the 2 over 3. On the bottom, 27 gets the 2 over 3. Now, when you're typing this into your calculator, again, when you have the number 8 to the power of 2 over 3, try to bracket, and I don't mean try, bracket, actually do it, the 2 over 3. Otherwise, you're going to get a different answer. So if you take 8 to the power of 2 over 3, you should get 4. If you got 21.3, you should not get this, which means you have to bracket your exponent. Here we get x, 3 times 2 over 3, I'm left with just 2. y. 6 times 2 over 3 gives me 4. And 27 to the power of 2 over 3 gives me 9. So this is all reduced. So just because we have a fraction doesn't mean we do anything differently. The rules still apply. Our calculations are just a little bit more difficult. So make sure to locate your fraction button ASAP. And like I said, if you can't locate it, please, please, please send me a picture of your calculator and I'll explain to you how to use it. Okay? So just to give you a little idea here, I'll give you right at the end, I'll show you my calculator and just give you an idea of what you're looking for. All right. Now is where we start with the new material. So that stuff should have been something we had seen before. Fraction exponents, maybe we didn't use them as much, but should have been somewhat familiar. So just a quick reminder, anything in blue you do not have on your copy, you need to write it down. Okay, so a radical is a number that is written in root form. So
are we getting a copy afterwards?
Pardon?
Are we getting a copy like after the session?
You have this copy just with the blue stuff not filled in.
Where can we get it?
Where do you get it?
I was looking for it, I couldn't find it.
If you go to the classroom, go to About. Do you have your folder here?
Yeah, but then it brought me to the homework that we had.
Do you have?
No, for me it's you want me to screen share and show you, or I'll ask you later?
Just, you can put your video up.
Okay.
Is anyone else having this issue?
Yes.
Yeah.
Yeah, we only have like 2 things.
Okay, sure. You know what? I'll just take care of this now.
Because for you guys, was it like when you opened it, you had the 2 assignments we had for homework?
Yeah.
Yeah.
Okay, yeah.
All right. Are we, okay, so if you check your stream, it should be updated now in the Google Classroom, so you should be able to open the PDF document.
Okay.
Everyone have it?
I have to check.
Yes.
Yeah.
Okay.
Thanks.
You're welcome.
Do we just print out the form and after we draw, what would we write?
Yep, so you can just, I'll have these uploaded the day before at the very latest, if not 2 or 3 days before. So you can just print them out and then basically all you need to do is write what's in blue. So anything that's in blue you don't have, everything that's in black is there for you.
Okay.
So you have all the examples, you have all the notes, just need to fill out what's in blue.
Sorry, so
Yep.
we're supposed to be getting, because I still only have like 2 things here. Are we,
It's on Google Classroom.
oh, okay.
It's on the stream. So you were on About, but there's also a stream. So click on the stream and it should be updated.
Nice.
Are we all good?
Yeah.
Perfect. So I'll just make sure to put it in the stream, that way there's no confusion. So I'll put your assignment will go in the stream, but I'll put the handout and the answer key in the stream as well, just to make sure we all can access it easily. All right, so we are now in the new material part of this. So a radical is a number or variable that is written in root form. So anything that has a root. For example, here we have the square root of 25, the square root of 8, the square root of 15. I can provide you with 100 different examples. It's all the same thing, as long as you see the root. Now, like I just said before, we have the 2 that we don't actually write. So anytime you have the root, that means 2 is the number we have there, but we just don't bother. So we just leave it as that. But just to know, this actually means to the power of 2. We call the number or the variable underneath the root the radicand. This 25 in this case would be the radicand for that example. A would be the radicand for that example. 15 would be the radicand for the third example. So that's just a terminology thing. So you may see the word radicand. You just need to make sure you're familiar with what this is. So just like with exponent, radical, remember, a root is an exponent. It's a fraction exponent. So we have similar identities and properties that we did for exponents. So some of them are similar, some of them look a little different, but the idea behind them is the same. So we have this main identity, okay? This is the foundation of this whole thing. So we have the square root of a equals b. I can change that. What this means is that b squared is a. So just to give you a number example to make this a little less abstract, if I say the square root of 4 is 2, what this means is 4 is 2 squared. We pretty much knew that. It's just a different way of writing it. So we're just working with this kind of idea. We have different properties that we can work with. So if we have a product underneath the root, I can separate this. I can say this is the root of the first times the root of the second. Okay. Same thing with a quotient addition underneath a root. I can say that this is the root of the first number divided by the root of the second. So just if we put some numbers in this, just to try it out here. We have the root of 2 times 3. This should be the same as the root of 2 times the root of 3. So if you want to test that out on your calculator, the root of 2 times 3 is obviously 6, so you can test out the root of 6, and then you can test out the root of 2 times the root of 3, and you should get the same number. That's why this is a property. Same thing here. If I have some sort of quotient, 1 divided by 4, let's say. This is the same thing according to this property as the root of 1 divided by the root of 4. So when you put this, make sure you put the underneath it, round it. You type this into your calculator, the square root of 1/4. You do the same as the square root of 1 divided by the square root of 4. This does not work adding and subtracting. So I have the root of 2 plus 5. This will not be the same as the root of 2 plus the root of 5. No way. So test on your calculator. You'll see if you take 67, it's not going to be 2 plus 5. It's not the same thing at all. Same thing for subtraction. If I have 5 minus 2, doesn't matter what the numbers are, it'll never work. This is not the same as the root of 5 minus the root of 2 at all. Think about it in terms of when we were dealing with exponents. You have the same base. There's nothing you can do here. So if you had a plus b, you couldn't make this.
Miss, for the addition,
yes.
is after the 2 plus 5 and does not equals, is that a 5 exponent
Root of
2?
2.
Oh, to the root.
Your root.
Oh,
Square
okay.
root?
Yeah.
Okay. And then square root of 5. These don't magically put together because you can only add and subtract like terms. Same thing here. The base is 2, the base is 5. I have some sort of exponent happening, exponent, I can't put them together. Doesn't work like that. Okay? Based on these properties, I can do different. So we're going to take a look at the operations. General note, like I just said, as with polynomials and exponents, you cannot add or subtract radicals that do not have the same base, the same radicand. So I'll give you a quick second to write this down. Okay. So we're clear. We're just nothing more complicated than that. So here I have a multiplication, so 6 times this is also written as 6 times the root of a. Using this property with more complicated examples in not too long. I have a multiplication, so I'm going to use this in reverse. So if I have a root times another root, what this means is I can put the numbers together under one root. And I know that 12 times 5 is 60. So these can be put together into one simple root. So the division here, same thing. When I have a root divided by another root, I can make one big root and just put the division underneath. And I know 6 divided by 3 is 2, so this just becomes the root of 2. Now this looks a lot simpler than this does, so we want to get to the simplest form as much as possible. So because we have a division, I could say this is the root of a divided by the root of 2. So they can be separated like this. What I can do is say, well, I can calculate 225. 144. These cannot be separated into two separate roots. So if you type in the root of 225 minus the root of 81, it'll give you 6. And we want 12. So do not separate them at all. All right. 64. So you have a choice. You could do the division first and then square root. Or you could not. It's up to you. Let's just do it this way. 100. Five over 4. So far, so good. What I want you to do, just quickly right now, I want to do a quick check-in. At least in a second. Later. Let's continue. Okay. The next thing we're going to do with these radicals, so we have these properties that we can work with. That's not the only thing that we can do. It's not the only thing we want to do either. So simplifying radicals. Just like with fractions, we want the simplest radicand possible. So with fractions, we wanted the most reduced fraction, but a radicand, the most reduced radicand possible. That is what we want. So what we are doing is we want to take out as much as possible from the radical. So it's two different things we're going to be doing, because with the radicals, we're going to have potentially going to be a combination of numbers and variables, and what we do with these numbers and variables is slightly different. The simplest radicand possible. We have numbers. What we're going to be doing is we are going to be factoring our radicand somehow. So there are two different ways we could do this. Either we could make a factor tree, or we could just separate into factors. So what you're looking for are factors that could be easily square rooted. For example, you're looking for factors like 16, 25. Because these factors, anything that can be easily square rooted, because we're the radicand. Yeah.
Like, how about, can you let us write the notes first? Give us like a couple minutes and then we can explain.
Absolutely. So I'll give you a minute and then I'll start.
I just have a question because I want to know if it's my mic, but like you just keep cutting off like a little bit. I just want to know if that's my problem or if anybody else is getting that.
No, I'm getting that too.
Yeah, me too.
Yeah, because like I can see on the bar
Okay.
like you're cutting off and it's like, I don't know, just a little bit.
Okay, so what might be happening if I'm cutting off is somebody who's not muted makes a slight noise. And then they take over. So that's why it's important for everyone to be muted.
Okay.
And only unmute yourself if you have a question and you want to jump in. Because otherwise, if you do a little paper flutter or something, that'll pick up and you'll become the focus and I get muted.
Okay.
Gotcha.
Okay? So just everyone take the time now again to mute yourselves. And then if you have a question, feel free by all means, unmute yourself, but only unmute yourself if you have a question. Okay. Someone's not muted.
Oh, jeez. Oh, is that me? No.
Yes.
Oh.
Okay.
Okay, just 1 second. We're just dealing with an issue.
Maria Liminos.
All right. So, here what we are going to be doing for numerical radicands. We are going to break the radicand into factors. So like I said, there are two different ways we can do this. Either we can make a factor tree and then take out all the pairs, or we're going to look for factors of 4, 16, 9, 25, anything that can be easily square rooted. So that is a perfect square. So what you're going to do then is you're going to take out any of the square numbers because you can square root those numbers. When you take them out, they get square rooted and they become coefficients. simplify your coefficients afterwards. So we're going to take a quick look at this, how we would do this. Okay. So we have 5 root 20. I'm going to do this 2 different ways. So I'm going to make a factor tree with one of them, and then the other one, I'm going to find different factors. Okay. So here, I don't care about the 5. I do care about the 120. So what I'm going to do is I'm going to take out 2s, 3s, 5s, stuff like that. I can take out a 2. So basically you're making a factor tree. If we go back to like sec 1, 2, 60, and then 60 can be broken into 2, and 30. 30 can be broken into 2 and 15. 15 can be broken into 3 and 5. Meaning that we get 2, 2, 2, 3, and 5 are factors. So underneath the root, I get 2, 2, 2, 3, and 5. Now what I'm going to do is I want to take out any pairs that I see. So these 2 are a pair. Even though I have another 2, it doesn't match with anything. So what happens to these 2 is they come out of the root, but it's 1, 2 only. So what happens is any pairs comes out as a singleton, and then I'm left with whatever I'm left with. These go together to give me 10. I can put this together. 2 times 3 is 6, times 5 is 30. So 10 root 30 is my simplified radical. So if you type in 5 root 120 and 10 root 30, you should get the same answer. It's just like with fractions. If you write 2 over 4, or I write 1/2, it's the same amount of pizza that I'm getting. If I have 2/4 of a pizza or 1/2 of a pizza, I get the same amount of pizza. It's the same idea. They just look differently. It's just cut differently. Same thing here. 5 root 120 and 10 root 30, same thing. Just this is simplified. Just like the fractions, we want the simplest. We want the simplest presentation possible. Same thing with radicals. So I'm going to do this one in a different way. So what you're doing here is you are trying to find factors that are perfect squares. So 4s, 25s, 16s, 9s. So I check my calculator, I type in 2592, and I divide by 4. Fantastic, there's a 4 in there. I'm left with 648. Let's see if that's divisible by 4. Even better, I get another 4. But that's all the 4s I'm left with. We have 162. So 162, is that divisible by 9? Yep. I'm left with 18. 18 is also divisible by 9. Fantastic. I'm left with a 2. So if I type in 4 times 4 times 9 times 9 times 2, I get 2592. Fantastic. Meaning this is a sort of factor tree. What is the square root of 4? Well, the square root of 4 is 2. So I have this 2 here, and then this becomes a 2. Looking here, what is the square root of 4? This becomes a 2 as well. What is the square root of 9? The square root of 9 is 3. I can do that again with this 9. And this 2 cannot be square rooted, so it must remain under the bracket. Then I can put all of these together. 2 times 2 times 3 times 3 times 2. 72 root 2. So if you type in 72 root 2 into your calculator, you get the exact same number as 2 root 2,592. So like I said, the idea is the same. We want the same value, but we want the simplest presentation possible. So what I'm going to do is I'm going to leave you a minute or two. I'd like you to try example number 3 using one of the two methods, either making a factor tree completely or just finding perfect square numbers that you can pull out of there. Either one is perfectly acceptable. So I'll give you a minute or two and then we'll do it together. All right, let's take a quick look at this together. So, like I said, either method, perfectly acceptable. So here we've got the 3. Now I want to pull out factors, so I can pull out a 4, because 720 is divisible by 4.
Hello?
Yeah, Miss, I think you're muted. Oh, maybe she just.
Is she frozen?
I don't know, like she muted herself. So.
No, someone muted her.
Yeah, it said Matthew Landry muted her.
Matthew.
Matthew.
You.
Am I unmuted?
Yeah.
Please try to mute, guys. Okay, just quickly before we continue, it was brought to my attention that some people are having trouble talking, so they actually can't type in the group chat. So I'm going to send out in the Hangout a different link before we continue. So there's a link there that was sent out. Training 1 is also me, so you'll see there that there's a link. Basically, that's an open chat, so if anybody is having trouble typing in the Hangout itself, you can type there, okay? So feel free to, I have everything open, so I'm able to see if you have questions or anything. So feel free just to type in there as well, okay?
I'm sorry, where do we type?
All right, so here we go. So broken this into different factors. Once I do that, I'm going to separate them because I can take the square root. I can separate it to that property. That says if I have a multiplication, this is actually the same thing as the root of 4, the root of 4, the root of 9, and the root of 5. Which means that I can do this. Well, the root of 4 is 2, the root of 4 is 2, the root of 9 is 3. And then I can put all my coefficients together, so I get 36 root 5. and I am good to go. So if you type in 36 root 5 or 3 root 720, you should get the same thing. Again, changing the appearance, not changing the value. Here we have 2 root 19. 19 we know has no factors. It's prime. What this means is there's nothing I can do. It's fraction 1 over 5. Well, you know this is reduced because 5 is prime. You know this is reduced because 19 is prime. Done. All good? Fantastic. We're going to do the same thing with exponents. So I'm just going to scroll down a little bit so you have access to the blue. I'll give you a moment to write down the blue, and then we'll get to explaining. Okay. If we're still not ready, just let me know. Otherwise, I'm going to start. An even number exponent is a square and can be square rooted, divided by 2, and removed from the root. So with variables, it's a little bit trickier because you can't just square root a number the way you would do it on your calculator with a number, okay? So there is a trick. Anytime you have an even numbered exponent, for instance, x to the 2, y to the 10, these are perfect squares. If we look, if I put this root here, if you remember what this means is y to the 10 over 2. It's actually y to the 5. Time we have an even number comes out by just dividing that number by 2. An odd number. For us, this is actually pretty simple. We're going to use one of our exponent properties, but backwards. Know that this is the same thing as y to the 10 times y to the 1. Because 10 plus 1 is 11 when I'm multiplying. Extend this here. I also know that I could say, well, this is y to the 10 times y to the 1, which means that I can apply this property and just divide this by 2. This is y to the 5, and this is just the root of y. Anytime you have an odd number, you're just going to split it into the biggest even number with 1, and then it comes out of the root. If you have an even number, it just comes out of the root like that. So let's do some examples.
Yeah.
Is that a question? No. Okay. All right, here we go. So here we have the square root of x to the 6. Now I just told you, we just looked, we have x to the 6. 6 is an even number, so this comes out just dividing 6 by 2, so it's x to the 3. That's it, that's all. Actually simpler than it is with numbers. Here, I have 7 and b to the 4. So the first thing I'm going to do is this 7 is a little bit of a pain. So I'm going to make this a to the 6 and a to the 1. And I still have my b to the 4. Anything that has an even exponent can come out. Just divide the exponent by 2. So a to the 6 comes out as a to the 3. A to the 4, well, 4 divided by 2 is 2. 1 can't come out because it doesn't have a pair, so it's just left underneath. So far, so good? Fantastic. All right, here we have a lot to deal with. We have a number and 3 different variables. We just deal with it one at a time. So we have 48 can be written as 4 times 4 times 3. So if you divide, we're looking for, again, you're looking for the 4s, you're looking for the 9s, the 16s, anything like that that can come out square rooted. I have a to the 3, that's a bit of a pain, so I'm going to write it as a to the 2 and a to the 1. B to the 6 is good, it's even. C to the 19, I'm going to write a C to the 18 and C to the 1. Now I'm taking anything out that I can. This can come out, this can come out, this can come out, this can come out, and this can come out. But when it comes out, it doesn't come out identical to how it was underneath. So each of the things, we're going to deal with it one by one. 4 comes out, I square root it, it's a 2. This 4 comes out, so I've used it, I'm going to cross it off. This 4 comes out as a 2 as well, gone. This a squared comes out, what's 2 divided by 2 is just 1. This b to the 6 comes out, 6 divided by 2 is 3. C to the 18, 18 divided by 2 is 9. Whatever is left goes back under the root, 3, A, and C. And I'm just going to make this look prettier because this looks really ugly right now. 3 times 2 is 4. A to the 2 and A to the 1 gives me A to the 3. B to the 3, C to the 9, and 3, A, C. So this is actually the simplified, the proper version of this right here. Changing the value, changing the appearance. Any questions?
Yeah, miss.
Yep.
Why did you divide it by 2?
So when I'm taking out a variable exponent, the variables get divided by 2. Okay? Because here, if we go back up, remember when we first started talking about roots. I'm just going to go back for a second here. The square root, if we remember, has the little 2 here. It's supposed to be a 2. It's close enough. And anytime we have a 2, anytime we have any number, really, whatever this number is, goes at the bottom of the fraction, the exponent. So when you just have this little 2, you're going to divide your exponent by 2. So when you have the square root here, what this actually means is, well, I'm going to divide the exponent by 2. So I just take whatever was there, 10 divided by 2 gives me 5, and that's the new exponent with the root gone away. So every time here that I have an exponent, here, this base with the exponent underneath the root, just divide by 2. That's all. So anything that's not divisible by 2, I want to fix so that I have something that is divisible by 2. So 7 is not. 6 is, and then I have 1 left over. And 3 is not. 2 is, and then I have 1 left over. 19 is not. 18 is, with 1 left over. So in that case, anything that's even numbered here just gets divided by 2 and brought to the front. So here this becomes this, the 6 becomes the 3, the 18 becomes 9. That's it. Okay?
Oh, yeah, I understand now. Thanks.
No problem. All right, so let's continue. Okay, so that's simplifying. Our brains are going back to fractions. So with fractions, the first thing we learned how to do was simplify our fractions. And then we learned how to multiply and divide our fractions. Then we learned how to add and subtract our fractions. So we're going to do the same thing. So I'll let you write this down, and then we'll take a look at it. Okay, so let's take a look. So we have this special property. So we looked just before when we multiply, divide, all that kind of stuff. Okay, we had this table here. That's when we multiply, I can just put everything under one root. Okay, so when I multiply, everything just goes under one root. And when I divide, everything can just go under one root. So we're going to be using that. The only thing that gets more complicated is when you throw some coefficients into the mix too. So this being a coefficient. The property says that, well, actually all I have to do is multiply the coefficients and multiply the roots. More complicated than that. So just like if you have 2x times 3x squared, I would multiply the coefficients, do 2 times 3, and x times x gives me x to the 3. So I did 2 sets of multiplications. I did the coefficients, and then I did the variables. Here I'm going to do the coefficients, and then I'm going to do the radicals. Same thing with the division. I have a coefficient with a radical, a coefficient with a radical, a division here. So what this ends up being is, here I'm dividing the coefficients, and then I am dividing the radicals. So we're going to do some problems just practicing that. So each time you're doing it step by step, one thing at a time. So here I have 2 root a divided by 5 root a squared. So the coefficients go together. So 2 over 5 becomes my fraction. In this case, it's not reducible, so I'm actually done. I don't have to deal with that anymore. Here I have the root of a and a squared. Inside this bracket, I can deal with this because I know how to deal with exponent things. So this actually becomes, this is actually extending all the way down, this becomes 1 over a. So like just we reviewed exponents at the beginning, just like with exponents, here I have 1, this little 1 that doesn't actually show up, and then 2. To reduce this, I have 2 minus 1, which gives me 1, and it goes on the bottom because the bigger number is on the bottom. And this is reduced. This is put together. You only ever want to see one radical. You don't want 10 roots in your problem. So here we do the same thing. Number 2. We have a coefficient with a radical, a coefficient with a radical. So we deal with the coefficients. So I have 5 times 6. And what's underneath goes into 1 radical. So this becomes 30. And this becomes the root of xy. And this is our simplified radical. That's all we want to do, is make it as simple as possible. The only thing is, what could end up happening, you put this together, you may end up with something that you have to take out. As we just saw, we want the simplest radical possible, which means we don't want any even numbered exponents here. And we don't want any numbers that could potentially be pulled out. So the next added step, just to be aware of and to pay attention to, is if you have to pull something out of this bracket. We'll do the same thing with these two examples. So here we have 12 root 20 divided by 4 root 5. So we take the coefficients and we divide them. We make one big root, and whatever is in the roots goes underneath the big root. In this case, 12 divided by 4 can be reduced, so that gives me 3. 20 divided by 5 gives me 4. Now you think it would be done, but because the root of 4 is something that can be taken out, I want to take it out. The root of 4 is just 2. So my answer is just 6. So we see this whole complicated radical thing. And it actually just turns into 6. Same thing here. We have the coefficients and one big radical. Whoops, I'm doing division. I should be doing multiplication. Little bit of brain issue there for a second. So I'm multiplying negative 30 times negative 6, just 6, and 5 times 8. This gives me 180. This gives me 40. 40, unfortunately, has to be dealt with. There's a 4 in there that can be taken out. So if it can be taken out, it needs to be taken out. So I have negative 180. 4 comes out as a 2, and the root 10 stays. And then I have negative 360, root of 10. This is all we have so far, okay? So if you type this into your calculator and this into your calculator, you're going to get the same answer. Again, that's what we want. We want the same answer, just presented differently. All right, before we continue, on your stream, I posted a question. How are we feeling about the material so far? So it's just a little check-in. I would like to know how you're feeling about the material. So you just click on the question and answer it. I'm not going to project your answers, but it's just for me to kind of check in with your pacing. So if you go and just click on that, just quickly answer it, and then we'll continue. Check it there, right? Classroom.
Miss, for question 4.
Yep.
What was wrong with the negative 180 to the square root of 40?
It's not simplified. So
It's not
remember with
simplified.
fraction, it's not. This 40 still needs to be dealt with.
Oh, okay.
Example, think of this, okay? You have, let me think of an example. 20 over 100. You decided you're asked to reduce your fraction. Okay. You divide by 2 to reduce your fraction. And you have 10 over 50. That's still not reduced, right? You're not done. You actually want to go all the way to 1 over 5. So basically, this part here would be this step. It's almost there, and we've dealt with it, but it's not all the way finished. This is all the way finished. Does that make sense?
Yeah, that's good. Thank you.
Okay. Just checking in here. Okay. So all of us have had time to, perfect, answer that question. Thank you for your feedback. I appreciate it. So we'll continue. Okay. So the next thing that we are going to be doing is just multiplication and division, but in this case, it's a little bit, our examples would be a little bit more complicated. Okay. So here, I'll let you copy these down. Okay. One last thing to copy down. Okay, so basically we're doing the exact same thing that we just did, just in a little bit more, the examples will be a bit more complicated. But the steps are always the same. So don't get intimidated by the bigger problems, follow the steps. Put the coefficients together. Put the roots together. We're going to simplify the root and then simplify the coefficients. That's exactly what we just did. So let's take a look at a couple of these problems. We have a bunch of problems to look at. So for A, here we have 13 root 7 times 14. So we put the coefficients together. In this case, this coefficient is 1. So we have 13 is my only coefficient. And then I have 7 times 14. Well, actually, there's a 7 in the 14. So I wanted to take these out. There are 2 of them, so they come out as 1. 13 times 7 gives me 91 root 2. And that is the simplified version of that. Same thing here.
Wait, Miss, I just had a question. Why did like where'd the other 7 go? Because isn't there 2 7s?
Yes, but when you take it, basically we're skipping the step that says, well, this is actually 7 squared,
Oh, okay.
right? So
Yeah.
because of them, it's 7 squared, and it comes out as just 1 simple 7. So anytime you have 2 of the same number, it comes out as 1.
Okay. Thank you.
All right. For the second example, again, put your coefficients together for x, y. Put your roots together. We have 3 and 12x. 12 can be broken apart. 3 and 4. So here, again, we use the trick where if we have 2 of them, it comes out as 1. So these are gone. The 4 comes out, the square root of 4 is 2. So it comes out as a 2. And then I have my x. This is ugly. I want to put it together. So 4 times 3 times 2 is 24. And all of a sudden, more simplified. I'm going to give you a minute. I'd like you to try C on your own, and then we'll try it together.
Just go back up real quick, please.
Yeah.
Absolutely.
Thank you.
I'll leave it here. I'd like you to try C, and then we'll start it together. Okay, let's take a quick look. So, just as before, if it's more complicated, don't worry about it. Follow the same steps. So, my coefficients go together. My roots go together. So now I'm going to simplify within the root and then take out anything I can take out. So I'm not touching the coefficients. Well, actually, I do want to touch the coefficients. That was a little bit of a lie because I have 6 divided by 2, which I don't want to have to do this. So this is just 3 over AB. Within the root, this 2 and the 162 can be simplified to give me 81 on the bottom. 1 over 81. So if you reduce 2 over 162, you get 1 over 81. Here, you get to the 3, and a to the 1. So that just gives you a to the 2 on the top. We are now going to use our rule that says if I have a pairing, it can come right out as a single. I'm going to use the same idea here. 81 can be square rooted. It becomes 9. It becomes, stays on the bottom. Here, if you want, the square root of 1 is just 1. So I've actually reduced this entire radical, and everything's gone. So now I can just put things together here. This and this goes away. 3 and 9 reduce. So I actually get 1 over 3. Okay. So these next examples are very complicated, or they look very complicated. Okay, so do not get overwhelmed. We're going to skip over them. We'll come back to them next class, just because there's one little thing I want to talk about, and we're almost running out of time. But we will touch upon these, or if you have time to do them on your own, you can.
Can
Yes.
you scroll up a bit?
Yep.
Thanks.
No problem.
Miss, when you crossed the a to where the 3 is, did you just square root that to bring a by itself?
Sure.
Yes.
Yes, exactly. So by square rooting it, the 2 just gets divided by 2, so it just becomes
So it just
a to the
becomes an a. Okay, thank you.
Okay, so actually what we're going to do is we will do one of the more complicated examples, just because I don't want to start something new right at the end, and I do want to give you about 5 minutes there to finish things up. So we'll take a look at H together. A minute or two to look at it on your own, and then we'll look at it together.
It's not showing the question.
Sorry about that. Yeah.
Okay.
All right, so let's take a quick look together. So we have 2 roots. We can't simplify anything unless they're all under the same root. So that's my first move. So what I'm going to do is I'm going to reduce all the x's, all the y's, all the z's, and go from there. I'll reduce the numbers. So if 125 divided by 900 into a fraction, it gives me 5 and 36. I have x to the 10 and x to the 5. That gives me x to the 5 on the top. Y to the 6, y to the 3. gives me y to the 3 on the top, to the 12, and z to the 5. It gives me z to the 7 on the bottom. If you notice here, you have all of the odd numbers. We don't care, because that's x to the 4, x to the 1, y to the 2, y to the 1, z to the to the 6, z to the 1, all under one big root. So now you're going to take out anything that you can. This x to the 4 comes out as x to the 2. This y to the 2 comes out as y to the 1. (36) comes out as 6. Z to the 6 comes out as z to the 3. What are we left with? Well, we're left with 5 and an x and a y on the top and one little z on the bottom. So that has the same value as the initial equation, but just appears differently in a more simplified form. Okay, so just to wrap it up, again, if you have any questions, feel free to email me all day, comment on the Google Classroom. I teach another class from 10:30 to 12:30, so I'll be able to answer you only after that, but I will get to you today, absolutely no problem. On the Google Classroom, you now have the first assignment. So I use Google Docs for this one, so there are 3 different questions. Take a picture of your solution and post it up, and I'll give you feedback. First thing tomorrow, during tomorrow's classes, we'll go over those questions. Also, handout for you to work on. Handout class 1, just to make sure we all have it. Attach here, just make sure it's all there. Okay. So you have the PDF. I'm not going to correct this. I'll upload the answers tonight. You can compare your answers. And if there are any questions, anything you have issues with, we can go over it first class tomorrow. Okay, so this afternoon, I will be posting the notes for tomorrow. That way you have time to look them over and print them out before. And I will be posting, tomorrow morning, I'll be posting the link to the Hangout once again, probably about 10 minutes before 8:30. Are there any last minute questions before I let you go?
Yeah, Miss, for the calculator, you said something about a fraction button.
Yeah, so take a picture of your calculator. And
Didn't you say you would take a picture of yours?
oh, I would show mine. Absolutely, I'll do that quickly now. So stop screen sharing. So here on your calculator, this is, it's a mirror image, so it's going to be a little bit difficult, but there's a button that looks like this one. Okay, so it's very, very hard to see. Let's see if I can. It says A, B/C. That's your fraction button, okay? Most calculators have it. If you want, not sure if it has it, just take a picture of it. So basically you use this and use that as a fraction. So 1/2, you'd hit 1 fraction button 2. Okay, so it makes your life a lot easier. So if you're not sure, this is an older model, so you probably don't have this one. But if you're not sure, just take a picture and send me your calculator. Take a picture, send it to me, and I'll let you know how to use that. Okay?
Okay.
So if there are no more questions, thank you for joining us, and we will see you tomorrow bright and early, 8:30 in the morning.
Thank you very much.
Bye.
Thank you.